Department of Collegiate and Technical Education welcomes you for Learning and Management System. Program First Year BE Common to All. Course Engineering Physics. Course code 18PHY12 Module 4 Laser Spark. Session 3 Learning Outcomes. At the end of this session, students are able to understand the available modes of vibration in the carbon dioxide state, principle, construction and working of carbon dioxide laser, key points of carbon dioxide lasers, and finally the possible questions. Possible energy states of vibrations in carbon dioxide state. First, bending mode of vibrations. Next, symmetric mode of vibrations. Finally, the asymmetric mode of vibrations. Now we discuss in detail each mode of vibration. Coming to bending mode. In this mode, both carbon and oxygen atoms will vibrate in the way the carbon atom moves upward while the oxygen atoms move downward. In the reverse mode, the carbon atom will move downward whereas the oxygen atom will move upward. This is the least mode of energy indicated by 0, 1, 0. Next, symmetric mode. In this mode, only oxygen atoms will oscillate, whereas the carbon atom remains fixed. The way in which both the carbon atom oscillate are about a fixed carbon atom along the molecular axis one can observe here. In the detailed form, you can observe in this mode, both the oxygen atoms are approaching towards carbon atom. In the other mode, both the oxygen atoms are departing from carbon atom along the molecular axis. It is the intermediate mode of energy indicated by 1, 0, 0. Coming to asymmetric mode of vibration. In this mode, all the atoms will vibrate. That is, both the oxygen atoms will move rightward while the carbon atom will move leftward along the molecular axis. In the other mode, the oxygen atoms will move leftward whereas the carbon atom will move rightward. This is the highest mode of vibration indicated by 0, 0, 1. Coming to principle, construction and working of carbon dioxide laser. Principle used in this laser is electric discharge or electric pumping. Construction. The carbon dioxide laser consists of a quartz discharge tube of length approximately 2.5 meter and area of cross section is 50 millimeter square. The discharge tube is filled with active media composed by carbon dioxide, helium, and nitrogen molecules in the suitable proportions. Per discharge tube, the electrodes are provided to produce electric discharge in the gaseous mixture as shown in the figure. The discharge tube, one of its end is fitted by 100% reflecting mirror, that means 100% silver mirror or else 100% mirror, whereas other side is fitted with partially silvered mirror. These mirrors will enhance photon density through multiple reflections in the active media. Once the threshold photon density reached, the laser beam comes out through partially silvered mirror. Working, the electric discharge is produced in the gaseous mixture. The N2 atoms will readily excite from ground state even to the higher energy state E2 through inelastic collisions. This is also called as pumping action. Here you can observe the nitrogen molecules exciting from E1 to E2. Now the N2 atoms will return to the ground state by transferring their energy to the CO2 molecules which are in ground state through inelastic collision. This is also called as resonant energy transfer. That means E2 of N2 molecules and E5 of CO2 molecules are almost equal. Therefore, the nitrogen molecules will supply enough energy per CO2 molecules to lift higher energy level, say E5. The CO2 molecules will excite to the higher energy level, say E5. Since it is a metastable state, the population increases in this level. That is, the population inversion could be achieved between two sets of energy level, say E5 and E4 and E5 and E3. Therefore, the laser action begins between them as follows. The transition between E5 to E4 generates a laser beam of wavelength of 10.6 micrometer lies in infrared region, whereas the transition between E5 and E3 generates the laser beam of wavelength 9.6 micrometer. This is also lies in infrared region. One can note down the energy emitted between E5 and E3 more than E5 and E4 because the energy gap between E5 and E4 is more, therefore which emits more energy than E5 and E4. Whereas the transition between E4 and E3 takes place through non-radiative transitions. E3 to E2 through the collisions with helium atoms of the mixture. Finally, from E2 to E1 through the inelastic collision with the walls of a discharge tube. Hence, the atoms are available for further pumping. Therefore, the laser become continuous output and more efficient. Key points of carbon dioxide laser. Output continuous wave and high power about 10 kilowatt. Active medium gaseous, that is composed by carbon dioxide, nitrogen and helium in suitable proportions. Population inversion by electric discharge, wavelength range infrared, that is 10.6 and 9.6 micrometer. Applications: high power carbon dioxide laser finds in automotive industries for welding, drilling, and cutting and soldering the materials, etc. In the field of medicine, for treatment of liver and lung diseases and other bloodless surgeries, etc. References: the biggest courtesy from Google Internet sources. These are the possible questions. What is the active media in CO2 laser? Why the N2 molecules readily excites to the highest energy level when the electric discharge produced in the mixture? What is the role of helium atoms in the CO2 laser? Mention the output range of CO2 laser. Define type of vibrations in the CO2 gaseous state. Write the modes of vibrations in the ascending order of their energy. Why one end of the discharge tube is fitted by 100% of reflector. Define different modes of vibrations. Thank you.